Okay, let's look at the homework 4.7, number 4. All right, so we have a right circular cylinder. So you have a right circular cylinder inscribed in a circular cone. So you have a cone like that. All right, then height is h. So this is the height. Oh, sorry, right here. So that's h. And the radius is r. So right here is r, right? Then you have a circular inscribed in a cone. So we're talking about the circular cone like this. So here, all right. So this is the circular cone. Not that perfect one, but here it is. All right. So I'm gonna just kind of focus on this triangular part and kind of slice it and then look at the cross section so that easier to set things up. So here's the triangle. All right. And here is H. And here's R. All right, then let's see. So we have a cylinder going like this, right? So I'm going to use x for the radius of the cylinder, right? And I'm going to use y for the height of the cylinder. So this part is the cylinder, right? Then doing the similar triangle, so I'm going to look at the big triangle and also this little triangle. So maybe I'll copy that little right triangle here. And we know that AA, angle, we know that these are similar triangle. So we can use the ratio. So here it's x, so it's going to be r minus x is right here. And that's going to be y, right? So we can set up a ratio. So we can do y to h. So y to h is going to be the same as r minus x over, so r minus over r, right? So from here, we can have an expression for y. So y is going to be h over r, because I'm multiplying both sides by h. Then you have r minus x. All right, so volume of the cylinder is going to be volume V is equal to pi radius, in this case x, squared times height, y. So that's that. All right, so let's see, since we have a way to rewrite y in terms of x, so plug this in here to get. All right, so you have pi, let's say h pi, so that's just, those are constant, over r is a constant. All right, then you have x times r minus x. All right. And if you want, we can just, distribute the x squared, so we can probably write it as h pi over r. Then you have rx squared minus x cubed. Right? So volume can be written in terms of the radius of the cylinder. Right? So we're going to take the derivative. So take the derivative of that. So v prime of x is going to be equal to, all right, h pi over r is just a constant. So we take the derivative rx squared with respect to x would be 2rx, and the derivative of x cubed is 3x squared, right? Then we can factor out x, so this is going to be h pi over r. Then x is pulled out, times 2r minus 3x. Right? Set it equal to 0 to find the critical number, but the critical numbers are x equals 0. And also, let's see, set this equal to 0. So that's going to be 2r over 3. So 2/3 r. Right? All right, so let's see. I want to, let's see, limit the x value. So x value only goes from, let's see, x is the radius. So you can go from 0. It cannot be negative, right? And since it's inscribed in a cone with radius r, so we cannot exceed r. So I guess I'm going to stop at r. All right. Then try to determine that actually one of these critical numbers, so maybe I shouldn't write that. So these are critical numbers, will give you the maximum volume. All right, so let's check. So since this is, we are trying to maximize over the closed interval, we can just check the critical numbers and endpoints. All right, so we look at the v of 0. This is the obvious one, but if you plug in 0 for x, it's going to be 0. Right? Then we have to look at one of the critical, the other critical number, 2/3 r. Right? So this is going to be, so it's going to be h pi over r. Then you have r squared, so it's going to be, square that, it's going to be 4 over 9 r squared. Just plug it in. And then if you subtract 2/3 r from 1 r, it's going to be 1/3 r. So it's going to be times 1/3 r, which is going to be, let's say, try to simplify. So there's 4. So you put 4, right, over, right, 3 times 9 is 27. So 27 is there. Then there's pi. So pi should be there, right? Then r and r cancel out, so there's only another r squared. Then you have h sitting right here, so times h. All right, so that's the volume. And when volume at the other endpoint r is going to be, this one is actually, again, it's pretty easy, because if x equals r minus r is 0, so volume is going to be 0, right? So we know that this is a positive quantity, and it looks like that's the only one that produces a positive volume. So therefore, this guy is the absolute max. All right, so therefore the volume, largest volume is 4 over 27 pi r squared times height h, all right, which is the right answer right there. All right, that's it. I hope that this was clear.